Hello, this is Dr. John Papazafiropoulos and you are watching another episode of the Science Broadcast. Today we're going to discuss why decision making should be made utilizing a number of data rather than just a single piece of information, which can be misleading. For this I'm going to use a personal example. I used to own a Dodge K, and that was an older Dodge when I was still an undergraduate student. That was one of the best cars that I owned. However, when you look at the data, the Dodge K car was one of the worst cars ever produced. How can we reconcile those two facts? Well, it is quite simple. We cannot make decisions based on a single piece of data. My experience with the K car was that it was a great car. For me, it was dependable. I bought it for a very low price, so it was cheap. I never had to do much to it. It did its job perfectly. However, my experience represents a single point of information, represents just one out of thousands of K cars. When we look at the history of the car, in other words, when we collect data relating to the K car, we realize that the car was actually plagued with mechanical problems, fuel problems, and it has gone down as one of the worst cars in history. So this little personal anecdote shows you how we cannot choose anecdotes or testimonies of our friends or other people when it comes to choosing a product or evaluating a product. One can have a very bad experience with something that is actually fantastic. This is where statistics come in place, and this is where sampling is coming into place. Sampling is choosing randomly items from a population to make decisions and evaluations. We cannot go and choose one item. For example, this is the weakness of Consumer Reports. Consumer Reports has gone out of its way to make a really great decision, and that is not to accept money or donations for the items they use and the items they check. However, very frequently, they go out, for example, and buy one car, they test that one car, and they make decisions. Or they go out and buy one blender, they test that blender, and they make decisions. Again, in statistics, the number n represents the size of the sample, and n of 1 is statistically insignificant. It cannot give us any answers. Therefore, while it is admirable that Consumer Reports does not accept donations, therefore they remain unbiased in their choices. Because the sample number is so small, we cannot draw meaningful statistical decisions or meaningful statistical answers from their tests. On the other hand, we have J.D. Powers. J.D. Powers accepts donations, so the bias is still there. However, they depend on a large N, as routinely they go out and they ask consumers their opinion about the product. The other weakness about that, however, is what questions they are asked and at what point of the purchase. If I ask more car owners, for example, about their opinions of the cars 2 or 3 weeks after they purchase the car, the likelihood of having very good results is very great. But what will happen 5 years later? Then the results will be quite different, even if I ask the same amount of people. Therefore, it's not just enough to have a large sample, but also choose the correct time and the correct questions to ask. A lot of times, we also develop emotional attachments to things. I know that I owned a car that I was very attached to in the past. That colors my impression of that car and my recommendation of that car, and it is kind of hard to capture in a standard statistical questionnaire. But we must be aware of that, and there is a statistical tool which is a qualitative research process in which we do not take measurements, for example, how often, in this case, the car broke down, how expensive it was to repair, how often I was without the car. But in a more conversational thing, like trying to recall times that the car presented an inconvenience, you're going to get two very different pictures if you stay strictly with measurable data that we call quantitative data, or if you mix quantitative with qualitative data. Often qualitative data might actually contradict quantitative data. So it is very important in decision making to make mixed choices and to be careful that we have a large enough N. In statistical analysis, the sample we choose must be both of sufficient size and representative of the population. What does that mean? It means that we cannot just go and just pick up anything, but it has to represent the population. For example, let's say we are looking at something that it is gender influenced, something that males and females do differently. While the tendency of many will be to go into a 50-50 approach, in other words, the sample being 50% males and 50% females, even if that sample is random, it fails the representative of the population test. And the reason for that is because the population is not composed by half men and half women. In reality, women outnumber men. So our sample has to have more women than men at the same proportion that the population does. In that case, we can ensure that the sample is proportional to the population. I hope this was a useful video, and as I said, we are going to make more scientific broadcast videos, and I hope I will see you soon. If you did like this video, please subscribe, like and share so we can grow this channel, which I believe has a lot of value. Also, I encourage your questions, and I hope to hear from you in this coming year so we can make broadcasts specifically answering your questions. Take care.